Well, hello students and seekers of truth. In this video, we can continue to study combinatorics, and we look at an extension or a slightly different example of what we had before. There are now 9 people enter in the race. How many ways can they finish first through third? Now, the important distinction here is first through third. We don't really worry about who finishes 4th through 9th, so we look at, again, a couple different ways. First place. Well, how many different people can finish first? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we can say that A, B, C, D, E, F, G, H, I. So there's 9 different people who could finish first. Now, out of those 9, there are going to be 8 other people who could finish second. So 1, 2, 3, 4, 5, 6, 7, 8 different people who could finish second. And then for each of those people who finish second, there's 7, 2, 3, 4, 5, 6, 7 different people who could possibly finish third. So if we were to write this, expand this, right? So if A finished first, then B could finish second, and C could finish second, and D, and E, and F, and G, and H, and I. Okay? And then for each of those cases, if A finished first and C finished second, then B could finish third, and D could finish third, and E, and F, and G, and H, and I. Okay? So if we look at that tree diagram, we can expand the work, or we can do the arithmetic as follows. There's 9 people who could finish first. For each of those 9, there are 8 different people who could finish second. And then for each of those 8 people who finish second, there's 7 other people who could finish third. Okay, so our answer here is 9 times 8 times 7, or 72 times 7, or 49, or 490 plus 14, so 504 different ways. Okay. Now, the final answer here is important. It's important we get it correct, but it's even more important that we understand how we got to this, right? So one way we can write it is, of course, 9 times 7 times 8, or another way we can write it is 9 factorial divided by 6 factorial. Because when we were to expand this, we would get 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And then 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1. And yes, I know that when you look at this, like, why would I want to write this out in such a long form like this when I can just do 9 times 7 times 8? And again, the goal here is not just the final answer, but to understand a pattern and to identify kind of a greater truth, a more abstract idea that underlies everything that we do. Okay? All right, so now let's look at some other examples that doesn't necessarily have to do with racing or running. Here, how many unique 7-digit phone numbers can exist? So there's 1, 2, 3, 4, 5, 6, 7 digits, and in the United States, that's what we use, without the area code, of course. And how many digits can exist? Well, one of the digits is 0, 0, 0, 0, 0, 0, 0. So that's 1, right? So another one is 0, 0, 0, 0, 0, 0, 1. Okay? And so on. So how do we count them all? Well, it's not too difficult. In the first digit, there are 9 possible, in the first slot here, there are 10 possible digits that can go into there, right? So you can think of this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers that you can fit in there. And then in the second slot, there's another 10. 4, 5, 6, 7, 8, 9, 10. Okay? So you can list it out this way. Okay? And then in the next level, there's another 10. And so it's going to be 10 times 10 times 10 times 10 times 10, 1, 2, 3, 4, 5, times 10, times 10, or 10 to the 7th power. Okay. And notice here an important distinction between this problem and the previous one and the one that came before that is that here in the racing example, every single level or every single place that we finish, the number of candidates that can finish decreases by 1. So 9 people could finish first, 8 people could finish second, 7 people can finish third. But here in this example, you have 10 digits for the first slot, 10 digits for the second, 10 digits for the third, and so on. So in this case here, it's like repetition is allowed. You can have the same result happening twice. Okay? Whereas in before, once a person finishes first place, they cannot finish second place. All right, here's another example. How many different license plates can occur with 3 numbers, 2 letters, and 2 numbers if the same character can be repeated? Okay, so let's just think about what this looks like. Okay, so a license plate here has 3 numbers, 1, 2, 3. So those numbers have to go in there. 2 letters, 1, 2, English letters, right? And then 2 more numbers, 1, 2. Okay, and how many possible license plates are there if the same character can be repeated? Well, to figure this out, we just kind of go through the list, the process we had before. 3 numbers. Well, in these 3 slots, there's 10 different numbers that can go in that first slot, 10 different numbers that can go in the second, and 10 different digits that can go in the third. Okay? And then 2 letters. Well, American or English letters, there's 26 letters, and they can be repeated. And then 2 more numbers. They can go in there. Okay, so altogether, that is 10 to the 3rd times 26 squared. Okay, so whatever that result is, you can put that into a calculator and figure out the number. It's 1,000. It's probably like a little bit more than 600,000. Now, in the second case, what if no repetition is allowed? Well, how would this change? Well, we can say that the first slot, you could put 10 numbers in there, and 10 digits in there, but the second slot, only 9. The third slot, only 8. Okay? And then with the letters, the first slot, you could put 26. The second slot, there's only 25 different choices, because, again, repetition is not allowed. Then this number, you're only allowed 7 there, and then you're allowed only 6 here. And so I'm going to write, so this is 10 times 9 times 8 times 7 times 6 times 26 times 25. But I'm going to write this a little bit differently. 10 times 9 times 8 times 7 times 6, that's 10 factorial divided by 5 factorial. And then 26 times 25, that's 26 factorial divided by 24 factorial. Okay, so this should be 24 factorial. So that's a different way of really saying the same thing. Okay. All right, now this gets me to this last point here, this general idea of factorial. We already saw some examples of this, but n factorial is just n times n minus 1 times n minus 2 times n minus 3, so on, all the way until you get down to 1. Permutations, we write this a little bit differently. So if you were to say there was some number, we would write P, or n permutations are. This is defined as n factorial over n minus r factorial. And for an example of that, we need to look no further than here. This example here, when we have 10 different digits to choose from, and we must choose 5 of them, and we're not allowed to have any repetition. So 10 factorial over 5 factorial, that's just 10 permutations 5. Or if we go backwards here, in this example, 9 people in a race, and how many ways can they finish first, second, third? So that's 9 permutations 3. because that's what this process is really here. It's 9 factorial over 9 minus 3 factorial, or 9 factorial over 6 factorial, or 9 times 8 times 7. Okay. So permutations is just like a special shortcut that illustrates a particular scenario of counting. All right, so now we've advanced things a little bit further. We made a distinction between repetition and non-repetition, and then we developed something called a permutation. We're going to end this video here and let you have some examples to work through and practice, and then in the next lesson we'll talk about something called a combination. Thank you for watching and have a wonderful day.